Right, in this lecture I will solve another example to find nth root of a complex number. In the last lecture we studied the formula and one example. In this lecture we'll solve another example using the basic formula to compute z to the 1 over n. Z to the 1 over n can be computed as r1. The complex number is first written in the trigonometric form, and then computing z to the 1 over n means computing r to the 1 over n, and this cosecant and this cosine and sine written as theta plus 2 pi k over n and theta plus 2 pi k over n both, and this k ranges from 0 to n minus 1. If you are computing z to the 1 over n, we'll go from z to the 1 over 3, we'll go from 0 to 2, 0, 1 and 2. We'll have 3 solutions. If we are computing z to the 1 over 4, we'll be having 4 solutions, and so on. Right. Given this number, let's solve an example. Given this complex number 1 plus j1, we'll first compute r and theta and then write this z in this trigonometric form, r cosine theta plus j sine theta. Putting the values of r and theta here, this number becomes this, square root of 2 cos pi by 4 plus j sine pi by 4. Now we know that we have 3 solutions for k is equal to 0, 1 and 2 respectively. Right. For k is equal to 0, let's find the first solution first for k is equal to 0. Right, z to the 1 over 3 for k is equal to 0, given this general formula, putting k is equal to 0 both places, here and here. We get pi by 4 plus this whole becomes 0, pi by 4 divided by 3 is 4 3s are 12, pi by 12 plus sine pi by 12. This is the first solution, first of the 3 solutions. The first solution. Right. Of course, the second solution would be for k is equal to 1, and the third would be for k is equal to 2. So for k is equal to 1, we'll replace this 0 with a 1 here and this 0 with a 1 here. So now taking LCM, 4 pi by 4 plus 2 pi 1 becomes 2 pi. So 4 is multiplied by 2 pi becomes 8 pi plus 1 9 pi. 9 pi divided by 12, and this is also 9 pi, replacing this k with a 1 because we are finding the second solution. The third solution of course would be for k is equal to 2, and we'll replace this k with 2. This k will be replaced with 2. So now this is 2 times 2 is 4 pi. 4 pi multiplied by 4 is 16 pi plus 1 is 17 pi. 17 pi divided by 12. So the third solution is 17 pi divided by 12. Second solution, this is the third solution. So now we have computed all 3 solutions given this complex numbers, given this complex number, and we are asked to compute z to the 1 over 3. If we would have asked to compute z to the 1 over 4, of course that would have 4 solutions, and if it is z to the 1 over 2, we'll have only 2 solutions for k is equal to 0 and k is equal to 1. Right, that's all for this lecture. Thank you.